An AI model is the trained brain that learns patterns from data. Before training, an AI system knows nothing useful at all. It only becomes intelligent after learning from examples. Once training is complete, the result is called a model. A model is what actually performs predictions in real life. It is the final product of the learning process. Think of it as a finished student after studying hard. Training data is the textbook, and the model is the learner. But unlike humans, it learns through mathematical patterns. It does not understand meaning the way humans do. Instead, it learns relationships between inputs and outputs. These relationships help it make future predictions. Every AI model is built for a specific task. Some models recognize images, others understand language. Each model is trained separately for its purpose. The model is created during a process called training. During training, it studies thousands or millions of examples. It compares its predictions with correct answers. Then it adjusts itself to reduce mistakes. These adjustments improve accuracy over time. After enough training, the system becomes stable. At this point, it is called a trained model. This model can now be used in real-world applications. It no longer needs the full training dataset. It only uses learned patterns for new inputs. This is what makes AI useful in real life. The model is like a decision-making engine. It takes input and produces intelligent output. But everything is based on learned math patterns. There is no human-like thinking inside it. A model works using internal parameters. These parameters are called weights and biases. They control how the model processes information. During training, these values are constantly updated. Better values lead to better predictions. Poor values lead to incorrect results. Over time, the system finds optimal values. This optimization is what creates intelligence. But this intelligence is limited and specialized. It only works well for the task it was trained for. For example, a model trained for faces cannot detect fraud. Another model trained for text cannot recognize images. Each model is specialized and task-focused. This is a key difference from human intelligence. Humans can learn many different skills together. AI models are narrow and focused on one job. That is why multiple models exist in AI systems. Each one handles a different type of problem. Together, they create powerful AI applications. But individually, they are limited in scope. A model does not store information like a database. Instead, it stores learned patterns mathematically. These patterns are compressed into internal structures. That is how it remembers what it learned. It does not recall exact examples from training data. It generalizes from patterns instead of memorizing. This makes it useful for new unseen situations. Without generalization, models would be useless in real life. The ability to generalize is the key strength. This is what makes AI models powerful tools. They turn data into usable intelligence, but they still depend heavily on training quality. Better training creates better models. Now we will explore how models actually work internally and how they generate predictions from learned data. An AI model works by converting inputs into predictions using learned patterns. Every model has an internal structure built during training. This structure contains millions or even billions of parameters. These parameters are what the model actually learns from data. When new input is given, the model processes it step by step. First, it breaks the input into smaller numerical values. Then it applies mathematical operations to those values. These operations are controlled by learned parameters. The model then moves the data through multiple layers. Each layer transforms the information slightly. Early layers detect simple patterns in the input. Deeper layers detect more complex relationships. Finally, the last layer produces a final output. This output is the model's prediction or decision. Everything happens through calculations, not human thinking. The model does not understand the input in a human sense. It only processes numbers and mathematical relationships. For example, an image is converted into pixel values. The model analyzes those pixel values mathematically. It looks for patterns like edges, shapes, and structures. These patterns are learned during the training phase. Without training, the model would produce random results. Training gives meaning to these internal calculations. That is why training is the most important stage. Once trained, the model can work on new inputs. It applies learned patterns to unfamiliar data. This ability is called generalization. Generalization is what makes AI useful in real life. Without it, models would only memorize training data. Memorization is not useful for real-world problems. Inside the model, every connection has a weight value. These weights decide how important each input is. Higher weights mean stronger influence on output. Lower weights mean weaker influence on output. During training, these weights are constantly adjusted. This adjustment reduces prediction errors step by step. Another component is called bias. Bias helps shift or adjust final outputs slightly. Together, weights and biases shape the model's behavior. They define how the model responds to inputs. The model also uses activation functions. These functions decide whether a signal should pass forward. They help the model learn complex, nonlinear patterns. Without them, models would be very limited. Activation functions make deep learning powerful. They allow models to handle real-world complexity. Each layer applies these transformations repeatedly. This creates a deep network of understanding. That is why it is called a neural network model. It is inspired by the structure of the human brain. However, it is still very different from human thinking. It does not have emotions or awareness. It only follows mathematical rules and learned patterns. Everything is based on numbers and computations. Even decisions are just calculated probabilities. The highest probability becomes the final answer. For example, cat might have 95% probability, and dog might have 5% probability. The model chooses the highest confidence output. This is how predictions are made internally. The process is extremely fast after training is complete. Models can make predictions in milliseconds. This speed makes them useful in real-time systems. From search engines to self-driving cars, it is everywhere. Next, we will explore real-world examples of AI models. AI models are already working silently inside many systems you use daily. One of the most common examples is recommendation models. These models are used by YouTube, Netflix, and TikTok. They study your watch history and behavior patterns. Then they predict what content you might enjoy next. Each recommendation is based on a trained AI model. Another example is image recognition models. These models can identify objects, people, and scenes in images. They are trained on millions of labeled pictures. Smartphones use them for face unlock systems. Security cameras also rely on these models. They help detect unusual activities in real time. These systems work by analyzing visual patterns quickly. The model compares input images with learned features. Then it makes a prediction instantly. Language models are another powerful example. They are trained on massive amounts of text data. These models understand grammar, meaning, and context patterns. Chatbots like AI assistants are built using them. They generate human-like responses to questions. They predict the next word in a sentence. This creates smooth and natural conversations. Search engines also use AI models heavily. They rank web pages based on relevance. The model learns what users click and prefer. Then it improves search results over time. Spam detection models are used in email systems. They classify emails as safe or spam automatically. They learn patterns from previous email data. This helps protect users from unwanted messages. In healthcare, AI models analyze medical images. They detect diseases like cancer at early stages. These models are trained on medical scan datasets. They help doctors make faster decisions. This improves patient treatment outcomes significantly. Financial systems also use predictive AI models. They analyze transactions to detect fraud patterns. They also predict market trends and risks. This helps banks and companies make safer decisions. Self-driving cars depend on multiple AI models. One model detects objects on the road. Another model predicts movement of nearby vehicles. Together, they help the car drive safely. These models process real-time sensor data continuously. Even navigation apps use AI prediction models. They calculate traffic and suggest faster routes. Agriculture uses AI models for crop monitoring. They predict weather impact and soil conditions. This helps farmers increase productivity efficiently. AI models are everywhere in modern technology. Even simple apps use hidden AI models. They improve user experience without being noticed, from typing suggestions to autocorrect systems. Every smart feature is powered by a trained model. These models work in the background continuously. They improve as more data is collected. Companies constantly update and retrain models. This keeps them accurate and relevant. AI models are not static systems. They evolve with new information over time. This makes them more powerful every day. But they still depend on human-designed training. Without humans, models cannot improve themselves alone. Now we will explore limitations and challenges of models and understand what they cannot do yet. AI models are powerful, but they still have real limitations and risks. A major limitation is that models only learn from training data. If the data is wrong, the model will also learn wrong patterns. If the data is biased, the model will repeat that bias in decisions. This is why data quality is extremely important in AI systems. Another limitation is lack of true understanding. AI models do not understand meaning like humans do. They only process patterns using mathematical calculations. This means they cannot truly think or reason independently. They simply predict outputs based on learned patterns. Overfitting is another common problem in AI models. It happens when a model memorizes training data too closely. Such models perform well in training, but fail on new data. This reduces their usefulness in real-world situations. Developers use techniques to reduce overfitting carefully. AI models also require large computing power to train. Advanced models need expensive hardware and energy resources. Training can take a long time depending on complexity. This makes AI development costly for many organizations. Smaller teams often face resource limitations. Another challenge is lack of transparency. Many AI models act like black boxes. We see input and output, but not the full reasoning process. This can create trust issues in sensitive areas. Researchers are working on explainable AI systems. These aim to make AI decisions more understandable. Data privacy is also an important concern. AI models are trained on large datasets from real users. Protecting personal information is essential and required. Strong regulations are being developed worldwide. Despite these challenges, AI models are improving quickly. New techniques make them more accurate and efficient. They can now learn faster with less data than before. This makes AI more accessible to different industries. Models are also becoming more adaptable over time. Future AI systems may require less training data. They may learn more like humans in flexible ways. Hybrid models will combine different learning methods. This will improve both performance and reliability. AI will become more useful in real-world applications. However, human control will always remain important. AI cannot replace human judgment and responsibility. It must always be guided by ethical principles. Fairness, safety, and transparency must be priorities. Responsible AI development is essential for the future. AI models will continue to grow across all industries. They will support humans in solving complex problems. From healthcare to education, their role will expand. But they will remain tools created and controlled by humans. They are not independent thinking beings. Understanding AI models helps us use them better. It shows how data becomes intelligence through learning. It also shows the importance of good training data. Every model reflects the data it was trained on. Better data leads to better outcomes and decisions. The future of AI depends on responsible innovation. Technology must be used carefully and ethically. Mistakes in AI design can have real-world impacts. That is why human oversight is always necessary. AI should support humans, not replace them. AI models are powerful tools, but still limited systems. They work through patterns, not true understanding. Their strength depends entirely on training quality. and their future depends on responsible development. The journey of AI models is still evolving every day,